Good day, my viewers. I'm going to take you on a topic, gravitational field. I have a question to solve for you, and don't worry, you enjoy the solution. See the question. The question reads, two spheres of masses 5.0 kg and 10.0 kg are 0.3 meter apart. Calculate the force of attraction between them. So, solution, let's bring out the parameters in this question. We have the two spheres of masses. So the sphere M1 is equal to 5.0 kg, and another mass which is M2 is equal to 10.0 kg. And the distance, let's say the distance R between them is equal to 0.3 meters apart. And the question is demanding for the force F between them. So from Newton's law of universal gravitation, we say that the force of attraction between two masses of M1 and M2 is directly proportional to the product of the masses and inversely proportional to the square of their distance apart. We are going to use this law in order to derive or to obtain the formula where we can be able to substitute and solve for the force as required in the question. So now for the formula now is equal to F is equal to Gm1 M2 over R squared. So the law that stated this is the connection between the force of attraction, the masses, and then the distance. Understand that this G is the universal gravitational constant, and its own value is G is equal to, it's not given in the question, but it's a constant, so it's expected of my student to understand or to know the constant. So the constant is 6.67 times 10 to the power minus 11 Newton square meter per square kilogram. So that is the value of the universal gravitational constant. Now we are going to substitute in these values into this formula in order to obtain the force required. So this is F is equal to G is 6.67 times 10 to the power minus 11 times M1 is 5 times 5 times M2 is 10 times 10, all divided by, and the distance R is 0.3 squared. Don't forget to square it. Now, we have 5 times 10 is 50. So we have 6.67 times 10 to the power minus 11 times 50 divided by 0.3 square will give us 0.09. When you square this, you are going to have this. Now, to simplify this one further, we can multiply 50 by 6.6767. So let's do the simple multiplication. 6.67 times 50. I'll bring down the 0 here, multiply by 5. So 5 times 0 is 0. 5 times 7 is 35. We write 5 carry 3. 5 times 6 is 30 plus 3 will give us 33. You write 3 is 3 carry 3. 5 times 6 is 30 plus that 3 will still give us 33. So we have 33. Note that the decimal places here is 2. So we're going to count 2 decimal places. So 1, 2 here. So the answer or the value of the multiplication between 6.67 and 50 is 333.50. So it means that our F is equal to 333.50 times 10 to the power minus 11 all divided by 0.09. Now we can write all of them in standard form. And by writing in standard form, I can write it as this decimal will move 1, 2. So we have 3.3350 times 10 raised to the power That is, it moves 1, 2. So if you subtract that 2 from 11, you are going to have minus 9. Or divided by, writing this one in standard form will be, the decimal will move 1, 2. So we'll have 9.0 times 10 raised to the power minus 2. Now we're going to divide this 3.3350 by 9. We simplify. So this will be equal to 3 divided by 9 is not possible, so write 0. Then you shift this 3 to this place, making it to be 33. And 33 divided by 9, the 9 will go into 33 how many times? It will go 3 times. Remainder 6. So bring the 6 here, making this one to be 63. And 3 into 63 will go, 9 to 63 will go 7 times. No remainder. Now, 9 into 5 is not possible, so write 0. We carry 5 over. 5 into, that is, bring this 5 and making it to be 50. Then 50 divided by 9, it will go 5 times. And since we have 4 decimal places, you can stop there. Times 10 raised to the power minus 2 will go up, so apply the laws of indices. We have minus 2 here, going up to multiply by 10 raised to the power minus 9. So this becomes positive. Under laws of indices, okay, let me write it down. We have minus 9 minus 2. So that will be 0.3705 times 10 raised to the power minus 3 become positive here. So we have minus 9 plus 2. That will be equal to 0.3705 times 10 raised to the power minus 7. Now the decimal is supposed to move one place since we are writing in standard form. This will be equal to 3.705 times 10 raised to the power minus this minus 1. So minus 1 plus minus 1 will give us minus 8. And you can leave it in this form, either 3.71 times 10 raised to the power minus 8 newtons. So this is the force of attraction between these masses of the sphere M1 and M2. I'm sure you enjoyed this solution. Please, if you do like this video, please don't forget to subscribe, share, and put your comment.